Hello there, this is exercise 16C. It's our last lesson on trying to find the standard deviation and the mean and the variance from a variety of numbers. And in particular today, we're doing a couple of other things as well, but we're looking particularly at frequency tables and how to still find the mean from a frequency table, and also now the standard deviation and the variance from a frequency table. So look, very quickly, a little start. If you type these numbers in, make sure you're in the right mode. Get yourself into mode statistics, one variable, and type those in and see if you can get the right answers. I want from your calculator the mean and the variance. So it says I didn't ask for the standard deviation, I want the mean and the variance. So I'm going to pause the video, give you a chance to do the questions, and then you can restart it. Now look, hopefully you've done it now. If you haven't, make sure you do. But if you have got these answers, let's see what answers I got. So I got the mean of 58. And I got a variance of 30.4. Now, if you have got an answer more like 5 or something like that, in fact, if it is something around 5.5, it's wrong, because what you've got to give me is the variance, and you've probably given me the standard deviation, but I want the variance. So don't make the mistake. Your calculator will say sigma x equals, and that's the standard deviation. You're going to have to square it to get the variance. Okay, so if you didn't get 30.4, it's because probably you gave me the standard deviation and not the variance. But the mean you should have got, that was obviously on your calculator, that's called x bar. Okay, some questions for you. So frequency tables are something we have had to deal with in the past, certainly at GCSE, and the good news is you can do these much easier if they let you, assuming they do, using your Casio class whiz. So it says find the mean and the standard deviation of the following data. Now actually this would have come up at GCSE quite a lot. You'd have got an X. Usually they wrote F here like this, these are almost always written downwards in your GCSE exam. The frequencies, it says, are 3, 5, 8 and 4. But what I remember having to do when I used to teach GCSE a lot was you ended up having to multiply these two numbers together. 1 times 3 is 3, 2 times 5 is 10, 5 8s are 40, 10 4s are 40. And then you added these up. What do I get there? 80, 93. And you add up the frequencies, that looks like 8, 16, 20, and you divide one by the other, and that will give us the mean. In actual fact, if you do that, notice the notation with the mean x bar, we're using this formula sigma x over n, which is 93 over the 20. Sounds like 4 and a bit, so if I try to do it properly on the calculator, I get 4.65, of course it is. So, but that will only ever get you the mean, and it's much more complicated to get the variance. You have to go through a process of squaring all the numbers. So I would rather we didn't have to do that. I would much rather we get our head into gear of how to do it on the calculator. And if they give you these numbers, you can always do it on the calculator. So press mode, like last time. I'll just run through. You press 6, which brings up the statistical mode, and then 1, which brings up one variable mode. And hopefully your calculator now has this. If you did the setup that I told you to do last time on the, I think it was the first 16b.1 video, you should have a frequency table. So you just need to now type that frequency table in, 1, 2, 5, 10, 3, 5, 8, 4, exactly as it says here. And then when you do that, remember you then press the option button, and you select one variable calc, which is number 3 actually. So it's one variable calc. So it wants we want to do one variable calculations, and when you do that, you should get these answers. So see if you do. I get a mean of 4.65, so that's obviously the x bar. It says on my screen is 4.65, and I get a standard deviation of 3.09. Again, that's the sigma x. It's 3.09. That's what I want you to do. Okay, make sure you can do that on your calculator. Then in addition, then we've got these, what we're going to call group data. Now at GCSE again, you might have had this written. That's the mass of some eggs, it would seem. It might have been written like that. it's between 100 and 120, but now I'm writing 100, 120. Notice a slightly weird brackets. Now it does say that this is actually, when it's a square bracket, it can be equal. So that really is equal. But when it's a curly bracket, it's not equal. So this next one can be from 120. Can be equal, oh, it was m, wasn't it? It was the mass of the x. I even put m there, I felt proud of myself. Get up to 140. In actual fact, it doesn't really matter. Because all really I'm saying is, these particular x, which there are 26 of them, were between 100 and 120. And it's very common to be asked to find, well, this says the mean. It usually will say the estimate of the mean and the standard deviation. Because really, I don't know what the actual weight of these 26 eggs are. I just know that there are 26 between 100 and 120. So I kind of have to assume that they're all 110, bang in the middle, the midpoint. These ones I'm going to have to assume 130, 150, 170, and 190. I'm going to have to assume that. But then what I want to do in my calculator is when I put it into my frequency table that I've shown you how to do just now, obviously we're going to put this number 110 as my x, and the 26 is the frequency. Then we go 130, 150, 170, and 190. Not sure if you really see all of that, but and then you put the frequencies in 26, 52, 84, 60, and 12. And then I want you to press the option button again, and I want you to get me, what's it asked for? The mean and the standard deviation. So get me the mean and get me the standard deviation. Okay. This is what I got. I got 148.3 and 21.2. So it's worth your while pausing the video, making sure you can get from your calculator, from this table, from those midpoints, with the midpoints on the left and the frequencies on the right. I want you to make sure you can get those answers. Then we've got another one. You've got to be a bit careful here. It says find the mean and standard deviation of the widths of the following pieces of wood. So you can imagine if I'm cutting wood like this male or female is doing, they have managed to cut two pieces of wood which to the nearest centimetre is between 0 and 9 centimetres. So basically when they measured it, this piece of wood here, it could have been, for instance, 9.2 centimetres because they have rounded it. And if it was 9.2, they would have called it 9. Now what this means is there is actually, and you can see the gap between them, that ends at 9 and that starts at 10. So there's kind of like some numbers which if you're not careful we'd completely miss out. So for that reason we use this boundary, this class boundary here is 9.5. And so when I'm doing this and I'm working out the midpoints, I have to really say, well, it could be anything from 0 up to 9.5. These 7 pieces of wood from 9.5, well again there's a gap between 14 and 15, goes up to 14.5. From 19 to 20 it goes up to 19.5. And anything up to this end, 29, could have been actually 29.5. Can't be 30 because then we would have had another box. So when you're doing the midpoints of numbers where there are gaps between the numbers, you've got to be very careful. So you've got to, when working out this midpoint, really, as I say, this is 0 up to 9.5. And that is 4.75 as a midpoint. This one is 9.5 up to 14.5. Now if you do that, I think the halfway point of those is 12. Now if ever you're not sure, by the way, you can, one thing that people do is they suss the gap between them, which is 2.5, and add it onto the bottom one, which gives you 12. Another way is to add the two numbers together, which if you do that you get 24, and then half it, and that will give you 12. So there's a variety of ways to get the midpoint. The critical thing though is that you're using the correct boundaries. What's interesting about that 12 is it's actually the number you would expect it to have got from 10 to 14. That's 12. And likewise this one, 15 to 19, if you do it, will be 17. 20 to 29, well that's a little bit different, that's 24.5. But in each case, for this, and this, the midpoint is exactly what you would have expected had you not thought about it. The one which is different is this bottom one. And that's because the 9 changes to 9.5, but the 0 doesn't change. Because the 0 doesn't go down to some mystical negative number, therefore it doesn't change. Therefore the midpoint is different to what you'd expect. Because, you know, you would have expected really 0 to 9 to be 4.5, let's be honest. So anyway, chuck that into your calculator, type in X and frequency into your calculator stats mode. Obviously the midpoint is what we use on the X. And then the frequencies are as they're written there. And I suppose that's the difference here, that you're not necessarily told these midpoints. And then press the option button, and then I want the X bar and the standard deviation. Does it say standard deviation? Yes, it does. Again, pause the video to make sure you get these answers. My answers, I did say be careful of upper and lower bounds, yes, exactly, are 17.3 and 5.71. So if you get that, 17.3 and 5.71, I think it said, then everyone's happy. Class boundaries, I need to mention this. Lots of times when you do this, there's no gaps between them. Notice what I mean by that. It goes from 0 to 10, 10 to 20, 20 to 30. So it's no real surprise that on these, the class boundaries are 10, 20, 30, because there's no gaps between them. And therefore the midpoints are what you'd expect. 0 to 10 we'll call 5, 10 to 20 we'll call 15, and so on and so on. 20 to 30 we'll call 25. So that's fine. Now, what about here? Gaps. This is what we were looking at just now. This was where you look at it and you go 0 to 9. Hang on a bit. The next one starts at 10. 10 to 19. Hang on a bit. The next one starts at 20. So there's a gap between the 9 and the 10. So we have to be careful with class boundaries. 0 is still okay. That 0 doesn't go down. But this goes to 9.5 because there's a gap. You've got to basically fill the gap. 19, 20. We better call that 19.5. We better call this 29.5. And so these are the boundaries, and as I showed you just now, that changes the midpoint. The first one particularly is the one that you should care about. Note that this only really matters for real life numbers when the data starts at 0. If there's a 0 which can't be rounded down, you see, like the length of a piece of wood for instance, you can't get a negative number for that, then you've got to take that into account with real life numbers. So look out for the zeros. If it starts at 0, that matters. And the last one is what I would describe as a special case for age, because someone who says they are 9, and notice by the way we definitely have gaps here, that says 9, that says 10, but someone who says they are 9, they could be, for instance, 9.5. You ask any really young kid what their age is, they'll say 3.5, 3 3/4, something like this. And in real life, someone who says they're 9, no one ever says they're 10, even if their birthday's tomorrow. So what's weird about age is that someone who says their age is between 0 and 9 could be very, very nearly 10. In fact, they could be like 9.9 years old, or 9.999. You know, they could be, wait 5 more seconds and I'm 10. But no one would ever say they're 10 until it actually strikes 10. So weirdly, the special case of age is someone who says they're 0 to 9, the boundary is 10. 10 to 19, the boundary is 20. 20 to 29, the boundary is 30. So the class boundaries are 10, 20, 30, 40, and the midpoints are 5, 15, 25. It's easier than it actually looks. One last question, just going to get you to do this. At 2 English seaside resorts, number of hours of sunshine per day measured to the nearest hour over the course of a whole year was recorded. And what do these results tell us? Well, obviously we're looking at Blackpool, we're looking at Brighton. Alright, so straight away I'm looking at this. The mean for Blackpool is lower than Brighton. So on average, it's like an average. On average, Blackpool gets less sun than Brighton. The standard deviation tells you how spread out the data are. So this is spread. And so you need to see what I've written as an answer. Secondly, the number of hours of sunshine per day in Brighton is slightly more spread out than it is in Blackpool. Bigger the spread, the bigger the standard deviation. So we'll be looking at some examples like that in class as well. And in class we'll do exercise 16C, expect lots of frequency tables, expect some questions where you have to show you understand what it all means.